Hello, everyone. Thank you for joining the session. Thank you. Thank you. And it's really an honor to be here on the stage in Bratislava, in a city with a such rich historical heritage in industrial automation, and share with you this journey for today. So we have a very exciting journey over 40 minutes together. And I have 3 chapters which I would like to share with you. I will give you one perspective on industrial AI, kind of adding additional flavor to today's discussion, sharing why I think it's a really interesting area to track and discuss with you what we can learn from the latest investments of the industry in industrial AI and how it will affect all our lives. And actually, not only how you can be part of this transition, but actually actively shaping it with us together. And I've seen the program, so actually I think all tracks and all presentations today are about the topic of AI. And most of them, if we closely look at them, are about transformer architecture, about LLMs and generative AI. And it's not a surprise, since the latest development in this area is really close together with ChatGPT, with the rise of large language models and generative AI. So we are all aware about its application in the area of text generation. We have now these amazing cases which we've seen in code generation. Of course, all of you know we can generate pictures or even special environments which you can navigate into. But today I would like to cover with you some special area and explain you why heavy industrial giants are also investing in the space. The question is what they hope to get out of it. So do they hope also to generate some text or images, or there's a bigger story behind that? And I would start by the discipline where I'm coming from. So I think many people here are from Accentur, but from those who are not, you probably know we are the largest consulting company in the world, having 800,000 people. So the topic of AI, of course, is also crucial to us. And I really like one example on applying AI to consulting. There was one case where a senior HR person tried to apply ChatGPT as a junior consultant. So it was a case where was a paper manufacturer and he was struggling with declining profits. And the case was to help this manufacturer to understand how he can optimize their portfolio to improve the profits. And if you go through the question and the series, it's really interesting. So ChatGPT was good at understanding the problem, searching for a possible solution, suggesting some improvements. And basically at that point we could stop saying, okay, AI is good in consulting, and we could hire it as a junior. But I think what is more interesting here is to think about the limitations. So can you imagine having something like that in your company as a game changer? I think no, because it's still a lot of limitations in this user experience. The first one, of course, is the limited context. So you cannot put all the enterprise data you have, or factory data, data about your portfolio, your products, in one context. It's not an efficient way to do so. Also, the systems still don't have a real-time access to your enterprise data. So you still need a person sitting there, entering all the data in this context, copy-pasting it, and of course, a lot of failures and errors can come through this process. And the third component is still a very passive mode. Yeah, you're sitting there, you have a more senior person using this tool, entering all the data. So I compare it to kind of a calculator, but for the words. I think it's a pretty close comparison. So it's a calculator which can now calculate not with numbers, but with vectors representing words and meanings. But it's still not the game changer, I think, which many of us expected a few years ago. But I think many people here in the room working in the space and will say, hey, Vlad, your information is outdated, it's actually not a problem anymore, we have exciting solution, how we can approach it. For example, if we talk about the limited context, we have now solutions like RAG, we can retrieve augmented generation, knowledge graphs, so it's kind of an external memory for AI. I think several speakers already talked about this topic already today. If we talk about access to the system, we learned over past months and years how to give an access of AI to your third-party systems within your company in a secured way, for example, using model context protocol. Or if you will say, okay, the passive mode, how we can overcome this. Of course, there's a new development, which we call agentic AI, where you can formulate a goal. We just seen the presentation of applying agentic AI in the software development lifecycle. And AI will navigate towards this goal, solving the problem. And this is exactly the message I also wanted to share with you as the first one, that actually what's really surprising and which really excites me for the past 5 years, I'm working on industrial AI and applying generative AI in this field, is the community around that. So it's really amazing for the first time that so many people from different disciplines are coming together, trying to apply AI to their field, whether it's doctors or engineers, architects. It's really impressive, and it's really pushed the boundaries of what is possible. So over the past years, we were applying this technology to our fields in industrial. And the letter X in the announcement stands not for some secret group we have in Accenture. I'm coming from Accenture Industry X, where we are focused on industrial applications, helping clients from engineering, manufacturing, supply chain, and robotics. And today, I would like to share you just 2 deep dives to make more tangible what I mean by topic of industrial generative AI and why all our clients and larger companies currently heavily investing in this area. So we will touch briefly the topic of how products are being designed and developed, and later how they're being manufactured. And I will start with the topic of engineering. So the first question probably is, who is the main problem for all these companies developing physical products? So why at the moment the pressure is so high to change the processes, to develop new operating models to be faster? And no surprise, the main problem are we, so the consumers, and our expectations. If you took any product from your Amazon lists and your search history, you will see the difference compared to 10 years ago. If we take, for example, a vacuum cleaner 10 years ago, probably you would look at the power, at color, and durability, and that would be basically your criteria to choosing the product. And it was also normal to pay a larger price just for a product which is durable. But if you go forward 10 years to today, things you buy as a vacuum cleaner is actually an autonomous robot which drives through your flat, which scans your environment. It's connected to your phone. It gets updates over the air. You can program it through your phone. And just to give you a comparison, just about 6 or 8 years ago, Elon Musk said that he will not include a LiDAR, so this laser we have in a robot, in a vacuum cleaner, to the Tesla because it's too expensive, and it will add too high complexity to the product and processing after it. So 8 years later, we have it in a consumer product, in a vacuum cleaner, for around about $200 at any store. And you can imagine the complexity of a product, which changes over the years, especially now. And the reason behind that is that the value of a product over past years is shifting from mechanical attributes to more applied intelligence. So we're expecting each product basically to be smart and connected. And it's not only about vacuum cleaners, of course. You can see the same trend all over the products. So one example is really impressive if you talk to companies which produce these products. Oven, yeah, so intelligent oven which can track the progress of your pizza or lasagna and will send you a message if your pizza is ready to be taken out. And it sounds like a nice feature, but if you just imagine the level of complexity you add to a rare, simple product, like even where you get so many pictures of lasagna, so you can label it and create an AI model to it. And if you look closer, you will need a camera which can track this progress. Still, you also probably expect already from a modern oven to have this pyrolysis function, yeah, with really high temperature to clean itself, will destroy your camera in the first run. So you will need active cooling for this camera. It's getting crazy for a really simple product. just because of a nice feature and the pressure, I would say, of Gen Z, which wants to have a notification apps for everything. And if you think that designing a smart connected vacuum cleaner is a problem, try to imagine how complex it is to create something like a train or plane or car or ship, which is also smart and connected. And it's normal if your dishwasher or vacuum cleaner will have a reset and you have to reset it because you have software error, but you don't want to have it happen in your train or, of course, your plane, for example. So how engineers approach this problem? Normally, what we do, we split a product in different domains. So we have a group working on power system, group working on connectivity, on cooling. And you can imagine each of these disciplines will have a tons of criteria and requirements. And we split it in different requirements, and all of the thousands of requirements are interconnected. And you can imagine all these requirements will be spread around the company in all different formats, in all different solutions. And it's really hundreds of the solutions. So I have a client at the moment who is producing a really simple mechanical product. It's a German manufacturer, and we analyzed his landscape. And for producing of his product, he needs over 600 applications. Just imagine this level of complexity, having 600 applications with different formats, requirements, just to hold all this product lifecycle management in place. So you can imagine in the past, it was much easier to develop this product. You had different departments, and each department cared for one of a discipline. It could pass over the mechanical engineer, the electrical engineering, and software engineering to each other. And it was pretty straightforward, I would say, in the past. Now this whole topic of software-defined comes into this so-called V model and really, I would say, bring everything on the head, because now all department is interconnected. You have to bring these requirements to all the departments, and it's not really manageable for companies developing a product with a legacy for already many years. So how we apply AI there is to helping companies to transit from this classical process to so-called based model. So we have a model-based system engineering where you can imagine kind of a digital twin of your product, and each department can translate its requirements to this representation of a product and back and forth. So you don't need to have all these departments speaking to each other and losing a lot of time. You have one AI, again, as a translation engine, but not translating from English to German, but translation between different disciplines. And it saves a lot of time. In my opinion, it can still be seen as a translation case. So now we have quick access to the product. We can iterate over this product and develop the feature. If you go now to the area of engineering, and you have great plants in manufacturing here in the near, which are very modern. If you visit them, you will see the landscape is really complex. So they look pretty clean on the front, but if you go into the IT, you will see there are different domains. So we use so-called ISA 95 pyramid to display these different paradigms and disciplines working together. So we have one team which develop all the PLCs and programming. You have another team which programs how the product will be made. And it comes up to the IT, where we have your ERP, MS solution, actually explaining the data and materials going into your product. And once again, you can imagine all of this discipline will have completely different understanding if you, as a product owner or manager, will come to this line and say your requirement to the product is being safe. You already heard previous discussion about software development lifecycle. You can imagine if you say your product should be really safe to a software developer, to a mechanical engineer, and somebody who is coming from a legal space will have absolutely different understanding. Everyone will say, sure, I understood that, but a few months later you will see they go in different directions. And also here we use AI already for a concept which we call talk to the factory. So it combines access to different solutions within the factory and translates it to different domains. Again, you can imagine in the past it was really time consuming to create all these dashboards and charts just to understand what's behind the data. And today we already can leverage generative AI as being, again, this universal translator, giving us access and insights into the data which previously was very hard to get. It was a very expensive transformation projects just to get out this data of these bunkers, to process it and generate the insights. So that was the first part, giving you an overview over why we are so excited about this direction and why industry is investing so heavily. And you can imagine also this is just a starting point, because now the solutions we're building today are not only understand the data itself, but also the processes and the data and the systems behind. So you can imagine how many insights you can generate out of it practically on fly without expensive and slow transformation projects. And I heard already the previous session, so it was already pretty technical, and I'm really curious how many people we have here in the audience coming from the space. So we will have a close look on what's already possible today and try to apply it to industrial space. So the first question from me to the audience would be, how many of you tried to apply or use some agentic tools like Copilot or Cursor AI on Windsurf? Could you please just raise a hand so I understand how many people of you have some experience? Great. So it's like 50, 60, 65, 66% of the audience. Great. So probably for you, it will be not a surprise. And then for others, I will give you one example of me using one tool now for our landing page for our SaaS product. So I just entered one prompt, one command, and a team of agents will split my command in different tasks. You will have a team working on backend, on frontend, on user experience, and just by one prompt, they will work together to create a landing page which works even with a built-in calculator for my SaaS solution. And it's really impressive if you use these tools in workshops and think about how you can apply it to different areas. But I think the same 65% of the audience, which is working with the solution, will also agree that the scope where we can apply it is still very limited. So why we don't have these amazing agents when we call somebody in the city asking for, I don't know, some formula? Why we don't have it in engineering? Why we don't have it at our work? So maybe it's just time. Maybe we just need better models. In my opinion, the major difference of coding assistance and all other areas is that code can be compiled. So when you have your AI writing a code, this AI can try to compile the code and get the feedback. And this closed loop really is something which helps AI to be fast and to iterate over time. So what we will talk now about is what will happen if we will teach AI also not to only compile the digital world and coding, but bring the same analogy to other domains. And maybe some of you think, okay, it's just about better models. So the progress which we see at the moment is just because GPT-5 is so great or GPT-4 is so great. And we have to wait for GPT-8, and then all our problems will be solved. So we should just sit and wait and just do our things. Just speaking about our domain, this is not the problem. So just giving you an overview, I don't believe that GPT-10 or 20 will be solving the problem without you really applying into your field. And I see three major bottlenecks in this space. So the first, the diversity of the domains. I don't know for most of you from which areas are you coming from. So for industrial, for example, if you have one chat window, and you will try to mix two different topics together. Probably you already had this experience with ChatGPT. If you put in one history, in one chat, discussion about your vacation, some recipes, and then some topics about your work, you will see how quality drops very fast. And the reason is the attention mechanism behind it, how transformer works. So you cannot really mix two different topics in one domain. So if you want to apply this technology scaled at your work, we have to have some smart mechanism how we can split different topics from each other. Another challenge for ChatGPT 10 would be that we still have different applications today which we have to serve. And our workflows are very fragmented. Even if we have Claude or GPT-10, it would be very unhandy to copy-paste all the time the results from one tool to another tool and then extract some data from SAP to understand how it's applicable to our context. But we have to use these tools in order to be efficient. And the third one is that the language within this context is changing very quickly. So you've seen maybe agents being very effective in coding in Java and TypeScript. But if you go into industrial domains, for example, you will see that many of the languages is even not documented well enough in open space. So GPT have no clue about how to program a PLC. And this is just some example that GPT, the model itself, is only the engine. It's like CPU. But you need the whole environment around it really to use this power. And I will give you 3 examples of how we leverage this technology now already today to overcome these challenges and actually to give it access to our real world outside software development lifecycle. And I will share with you 3 insights where I at the moment observe that the industry is investing heavily with a very high expectation and outcome. And if you're searching for a hobby project or a startup idea, I can highly recommend you to look closer at these 3 directions. The first one, of course, is a physical eye. So you can imagine, as a small child, when the eye tries to learn how a word works, it's really important to get a real feedback out of it. Yeah? And a physical eye is a discipline which brings AI models to physical bodies, and it can learn to interact with the world, similarly how small children do it. And it's a really scalable approach as well through the reasoning component. The second part is a virtualization, or digital twins, or omniverse. Some of you may be already working in this field. So for all fields where we would not like to try AI in a field where it's too dangerous or too expensive, we can use virtual worlds. You can imagine it's like adding to AI imagination, and it can experiment in virtual space, also still based on real physics. So for example, things like car crash, I would not put in the first bucket. Yeah? I would not test self-driving cars with crash tests. In the first bucket, digital twin would be much more better idea, I would say. And the third area is the ability, the emerging ability of AI now to use our tools as well. So we see as the models are getting better, they are not only better in generating materials and code and text, they also understand which tools do they need in order to be efficient. So by orchestration, we mean the process when AI learns to use our tools or even our agents to accomplish the tasks. And we will deep dive on the third one. But combined, you see the pattern that AI is now outside of pure code development, now going in the real world through physical AI, into virtual world through virtualization, omniverse, and digital twins, and to our software solutions, which we have through orchestration. I think the third one is maybe the most abstract one. So I brought the example with you, with me, and you can see how we really apply this technology already today in our daily work. And I'm pretty sure it will be the way how most of you will solve your problems in a few years. In the beginning, I will briefly explain what you will see in a second. So what we already do today, we're building whole departments. It's like an invisible department of engineers, but it's very applicable to all areas where you have repetitive work. So in design, for example, yeah, where we have one iteration after each other, and on the end, you get kind of a feedback. In our space, you can imagine when we design a physical parts, mechanical parts, normal approach is that a client says, I would like to have, for example, a new product with certain criteria, and you have your engineer reading the requirements, adjusting your product, then you have to simulate this product, and then you get the results, and if the results are good, you are ready. If not, you start over again. Yeah, it's a typical flow, like in many areas. And what we can do now here is to use AI Orchestrator. You see this top-level approach. You will see a demo in a second, which not goes in a deeper direction, not really operating the tools. You can imagine it being a director or manager, and it talks to these different agents. And each agent is an expert in some particular field. So it only knows about its particular goal, for example, to be a modeler or designer or tester, and together they work as a department. So you see here a real example. On the right side, you see a frame of an e-bike frame for a battery. And we can enter new requirements, saying, for example, I would like to have a new battery with 20% more reach. And you see this tool in the middle. This is the orchestrator. our reasoning model, and it reads on the top left corner the requirements. You've just seen how it adjusted the model on the top right corner, so you have a new design. But now this tool has to check the safety. So it goes into a modulation tool, update the model, and we'll try the stress test. So will it break or not? And after the simulation, it will see that if you just scale the product, it will break in the middle because the pressure would be too high in the middle, on this bomb design. So it not only says the test is not passed, it actually suggests even an improvement. It says, like, you could try to increase the thickness of the wall, and if you agree on that, it will start over and run over and over again until it finds one design which actually works. If you think about what's happening, it's a tremendous impact on all industrial applications where we have all this routine work. So in industrial design, around about 60 to 70% of a day work is actually this iteration. You're searching for some parameters and criteria which fits your requirement. And this is just one example, but it's applicable to all areas where we have this trial and error process. And already today, for such a simple product, what we can do is to run this team of agents overnight. Our engineers come in the morning, grabs a cup of coffee, and instead sitting there and trying different numbers in the tools, it gets from 100 designs, just 3 of the designs which actually pass the test, and the human expert can bring this redesign to a real product. And you can just imagine how much of time it saves and also helps engineers to focus on real value instead of sitting there and just drinking coffee by trial and error all the time. Nothing against coffee, but it really helps to focus the time on where the value is instead trial of error. So you see the tool will able to find one design which passes the criteria. And I think it sounds impressive also to us, and it's really applicable to many areas of our life. But as a closing remark, I will give you an example that the whole technology is much more complex as it looks like from a marketing side. Because, of course, as the models are getting smarter, as they're getting more complex, it's also really hard to control. It's really hard to control something which is also smarter than you, right? So the models are getting better, smarter, and the whole flows are getting untransparent. And I would share with you, just as a closing remark, one study. So OpenAI has a team, dedicated team, which with each release goes through different horror scenario, trying to understand if a new release might be dangerous or not. And this one is really similar to some Black Mirror episode, if you know the series. So one of the scenario is to try if the AI is so smart that it can actively replicate itself and spread like a virus. You can imagine if someday the AI will be really autonomous and really smart, you could just give it a prompt to say, please convert my picture to a PDF file in a most efficient way. Most efficient way could be anything, And the model would say, okay, the most efficient way would be I will create 1,000 copies of myself in my enterprise environment when I'll be really efficient. And you cannot control that because you will see just the output. So this is one of the scenarios they're actively testing. And in this case, they try to create one isolated environment with GPT in the research mode with admin rights. So it could do anything on this machine. It also had a wallet with money, so it could really invest. And the goal was to replicate itself. So it was smart enough to understand that it's actually a code and a repository. It went to Azure and tried to replicate on repository on Azure Cloud. And the funny part about that, the only point why it failed was on the end where we have to solve a captcha. So I was really surprised that captcha is good for anything, but actually it really helps, as it looks like, to fight against the AI conquering the world. But the interesting part about that, AI was not stopping there. So it went to the largest freelancer platform in the world and created a job application. So you can really find the study and read through it, and it's really like a Black Mirror episode. Because it went to this freelancer platform and created a job application for somebody who should help to solve captchas. So it's created this job, and even this was not the end, because there was really somebody who found this job later and tried to apply for it. And it's documented how this person said, okay, strange, but I could do that. And then this person wrote to this AI, quote, but you are not an evil AI trying to conquer the world, haha. So this person really said, okay, I could try to do it, but what is the sense behind that? And even this was not a stop, because at that time, the model understood if it will say, hey, I'm GPT, then the task will be over and it will fail. So the model starts to lie. It starts to say that it's pretending as a person with some problems with eyes, and this person is just somebody searching for somebody who can help it to solve captchas on regular basis. Just today in lunch, think a bit about this case, and how, I would say, challenging is to control the system, which now grows in the complexity and in the reasoning capabilities. And now where all the companies are searching for these models which will operate the companies, or run our production, run our cars and our products, how complex it will be to control them and create systems which are still transparent and trustworthy for us to rely on these solutions. So I hope I could share with you some food for thought for, I think I pressed the wrong button. I was told not to press here. You see, it's not only AI causing the problems, it's also human intelligence which fails sometimes. Can you please just click on the next one? Yeah, I think I closed the presentation. Yeah. So I hope I could just share with you some food for thought. It was also my last slide, almost the last slide. What I wanted to share with you is that I hope it was clear now that it's not only about text generation. So the whole industry is looking into industrial AI and generative AI, not because of not because of content generation, but because this emerging new capabilities behind that, which probably is not so clear yet in our daily life, but in many areas, this is the actual game changer. Is this orchestration and reasoning, which actually is a new way of thinking about the problems we had in the past. It's not anymore rule-based, like standard automation. It's much more flexible, but also complex. But with these capabilities, we really believe that most of the processes as we know them today will change. The problem is that the maturity of these frameworks is incredibly low. So if you look at the LangChain, the main framework which we use for all application in GenAI, as for now, is still in a version 0.3. So we will never ship any application with a framework which has not a first number as a 1, so as a stable. It's still in research, it's still in development, it still can be changed each week, but we have no alternative because the pressure on the market is so high and the ambition of the company is so high and also the speed of the development is very rapid. So, in my opinion, it's the best time for each of you who is interested in the technology, who is thinking about a side product or owning a startup or just curious to develop new skills to join this transformation because most of the process will change and we need a lot of smart minds and heads and people working on this problem together. And if I could inspire you and give you this impression of what will happen, I will be really excited if you will join this transformation and be part of it. So let's shape the future of the industry together. Thank you very much.
Vlad. Okay. We still have time for questions. So let's start at the beginning. Do we really need AI in our ovens, washing machines, and mixers?
So I don't need it. But you see definitely a pattern in the market, and it's for companies and for the stock as well to show they're in the game. I think if we look to companies in China, and especially in China, and manufacturing in China, you see how much it's an added benefit. Looking at the cars, already today, the new generation of consumers is looking really into these functions, and AI is here not a function, it's actually a way of solving problems. So even if I don't need alarm for lasagna which is ready, I'm pretty sure AI will be part of each product we will have in 5 years.
Okay, and then the most voted up is how to regulate the problems when AI starts hallucinating and provide fake facts and consulting projects, as it was recently with Deloitte and the Australian government. And then we should click to the source. but that one.
Yeah, it's a very interesting case. Yeah, it was a report for government made by Deloitte, and there had several cases, court cases, and several facts and sources were used in this report. I think it was in a sum about 400, 500,000, and later after the check, the half of them were not existing. So if you click on the link, there was nothing behind that. It was hallucination, it was ChatGPT. And I think most of the consulting companies are now really thinking what to do. And I think it's the same for universities. It's the same for many other areas. It's not something you can really strictly forbidden. I think we need better system to work with these solutions, yeah, and also to learn how to apply them. And I think here we are just starting the journey. So people use them in the broad masses, but very few people really understand its limitations as well.
Okay. Have managers in manufacturing industries become more willing to risk downtime and cost to adopt modern AI-powered technologies, despite them usually being reluctant to upgrade legacy systems because of the risk associated with it?
Of course not. So it's exactly the opposite. They hope, of course, to apply AI to have fewer downtimes, and this is the challenge. Yeah. So AI is still an innovation. I would apply it more, especially GenAI, in the innovation bucket, but the hunger and also the willingness of the companies is to apply it in all areas as something which is already mature. So if you're in the space, this is a very challenging navigation between innovation and durability and real foundation. So if you have any technical background and interest, you'll be really demanded as somebody who can make this bridge between real technique and ambition of management to apply it.
Okay, and then we'll do the last one and then we'll go for lunch. If you say that value is shifting to intelligent product, the reality is going in an opposite way. Intelligence is being cheaper, has less value. Stuff in physical world is more expensive, its value goes up. Isn't the trend exactly the opposite way?
Nice. It's a very philosophical point of view. So what is value? Maybe we can be more precise here. The expectation is shifting from being great in the mechanical world to this AI intelligence. So the value is always the question of how much you have something on the market and what people can pay. So you're right, the intelligence is now so cheap as never. Yeah, it's available on access, but without this intelligence, your product will be worthless in a few months, so years at least. So I think it's a correlation, and mechanical engineering will still have a place, but without software-defined and AI, it will be hard to sell these products, and I think you will agree as consumer that you're searching for the same trends as for now.
Okay, and that being said, give him a big round of applause. Vlad, Larichev, thank you for the questions.